Everybody ready? There we go. Look at that. We got somebody in here excited. So we're going to start this one the same way we start the rest of them. If you like taking pictures of slides, I'm going to put this one right up front so that if the pager goes off, if the text messages go crazy and you got to leave before we get to the end, this is all the resources that you're going to need. This is everything that we've presented in the session. This will be all of the code that we use on the back end to build out the demos that we put together, and it will be all of the resources, the documentation, the Learn modules, everything about the technology that we're going to talk about. It also includes the presentation. So our hope is that you walk out of here and you take all of this stuff and tear it apart and use it for whatever you want to. Go play with the technology, go play with the documentation, use the presentation to help build training materials or documentation internal to your company. We want to make sure that we're as open and transparent as we can with all of the content. So let's focus on storage in Azure. We're going to talk about a couple things. We're going to talk about why cloud storage, particularly for people who have a long and glorious history of trying to manage storage on premises. The idea of why would we want to move that to the cloud is the first thing that we have to answer before we start looking at what are my options and how is it that I can leverage it. Then we'll talk about introduction to cloud storage options. We'll look at all of the different fundamental storage pieces that Azure has and how we can put things in there and what we can do with it. And then we'll jump into our first demo. And we're going to look at the Azure portal, and we're going to talk about storage accounts and creating storage accounts and what can we do with them and what do they look like and how do we move around in them. We'll talk a little bit about some of the ability to automate them. So being able to do things not just with the portal, but with the larger automation ecosystem that exists around Azure. Then we'll talk about Cosmos DB. We'll talk about the first of the managed data storage environments that we have in Azure, and we'll do a demo about that, and we'll look at some of the features and functionality that Cosmos DB brings. And then we'll talk about the tried and true. We'll talk about SQL servers. We'll talk about the open source relational databases and relational database platforms that are supported inside Azure. And then we'll look at some of the advanced functionality there. We'll talk about Azure Data Factory a little bit, and then we will finish off with SQL Data Warehouse and how do we automate collecting and storing some of the pieces that we have in there. So there should be a little bit for everyone. For those of you who are still using storage on premises and you're trying to figure out, do I use block or file, or when do disks come into play, or how does all that work, we've got a bunch of that for you. If you've decided that data storage from an application standpoint or from a development standpoint is something that gets done inside databases, we've got a fair amount of that. We've got a little bit of demo for each of them. Sound good? All right. Let's kick off with the basics. The question that we're asked, or the question that customers first have to clear as a hurdle before they start talking about how are we tactically going to implement this, is why cloud storage? Why would we want to put data in the cloud at all? From my perspective, that answer really has 2 points, and that's first, reliability. How can we make sure that the data is available, make sure that the data is available at the performance that is required with the latency that we can handle? And then second, security. How can we make sure that the data only gets where we want it to go? How can we make sure to assess vulnerabilities that we have of the data by the applications that are sitting in front of them or by the databases that are hosting them? If we can focus on the availability side, the reliability side of things in storage, and then look at all of the different things that Azure makes available for us, not just making sure that the database is always available, but being able to tune that database for specific performance or a specific balance of performance and cost. Being able to look at different strategies, whether we want to go with an open source version of a relational database, whether we want to stick with the SQL server that we've been using on premises, all the way in through how do we monitor these? How do we manage them? How do we troubleshoot things in them? How do I leverage the technology to be able to take the operational burden off of the operations teams that currently have it? And how can I leverage Azure to be able to take on more of that? How can I maintain the concept of storage tiers, or maintain the concept of global distribution of data so that it's as close to my customers as possible, which I know how to do in an on-premises world, but now I need to figure out how to put that out into Azure. If we can focus on reliability and security, I think from a feature set and a use case standpoint, the rest of it falls in line. This is, I think of all of the slides, this one is pretty basic. This is a spectacularly hard slide to pull off from an Azure standpoint. As someone who spent most of my career in infrastructure, both as a consumer, as a customer, as a service provider partner, and then as a vendor, I'm used to, when we look at products, looking around, what's the launch calendar look like? When are we going to do an update? When is there going to be a refresh? And then all of the resources for that, whether it's documentation, whether it's marketing, whether it's events, kind of circle around those dates on the calendar. From an Azure standpoint, internally, I get a 2-minute podcast a day to cover everything that changed in Azure in the last 24 hours. There is no launch calendar. There is no slowing down the development process and the rollout of new features and upgrade of existing features and acquisitions of companies that we then expose as new products that we can deliver through Azure. And so distilling all of that down into a single slide so that we can start to make some sense out of where are we looking or which part of the discussion are we having. There's probably been more versions of this slide since I started working at Microsoft than any of the rest of them. I like this one because it covers the things that are important. We've got the edge devices. How do we take the cloud and expose it out to the furthest reaches of the data center where the data is and where the users are? On the bottom of it, we've got the infrastructure. Right? On the right side of it, we've got the tools. How is it that we interact with the cloud? And then in the middle is the value proposition, is the what can we use that ends up making this entire environment better. The infrastructure at the bottom is boring. Nobody wants to deal with it. It needs to be there. It always needs to work. It always needs to be available. It's the Lego bricks that are far less interesting before you put them together into something fun. Storage is both the best and worst of these from a boring standpoint. We don't care how it does what it does. All we know is that there's no bad day like a storage bad day. I can reboot a compute instance. I can reconnect a network. Once data's gone, data's gone. And so the idea that these fundamental infrastructure pieces all boil down to something that we want to be able to take for granted as a service, that we want to be able to be available, but at the same time we recognize that if something goes wrong here, it's going to have a significant amount of impact, is one of the things that we keep in mind as we roll out not just the core services, but then everything that we build on top of them. And no matter what we do from an Azure perspective, we know that this doesn't exist in a vacuum. We know that for everything that we build on the Azure side, there is a corollary that you're running today on premises. You have operational databases, you have data warehouses, you have places where you're aggregating this data together. You have different sources that you are collecting that data from, whether it's line of business, whether it's IoT edge devices, whether it's applications, whether it's users. Our job is to try to normalize the experience as much as possible across the two. And that means programmatically, how do we make sure that the automation exists across the two of them? That means from a tools perspective, how do we make sure that you don't have to change your worldview from an operational standpoint simply to jump into what is just another database product or just another storage product that happens to be running on Azure. Our customers are very clear with us that they need 3 things from us out of this process. The first is you need to be able to work across your data cleanly anywhere. So whether it's on premises, whether it's in the cloud, regardless of what region it's in and regardless of what product you're using, there are tools that you want to be able to use, whether it's things like R and things like Python. There are functions that you want to be able to use to reason over that data regardless of where it is. The second is that you want to have flexibility in your choice of how you deploy that data. And so whether that's the deployment methodology, I want to deploy it on Windows, I want to deploy it on Linux, I want to deploy it in VMs, I want to deploy it in containers, or whether it's on top of it. I want to be able to use Java, I want to be able to use JavaScript. I want the things that I currently use to work on that data available to me, even if I'm procuring that from the cloud. And then finally, the security and performance has to be there. And whether that's certifications, whether that's secured regions that we deliver services in for specific audiences, The security that we create on premises has to be able to translate into the cloud, or that's a gap that's really hard for me to overcome from an availability standpoint with the business that I'm trying to run. There are going to be differences between these two. As much as we want to try to normalize the experience and normalize the technology, there's going to be things that are different. The first one is going to be on the cost effectiveness side. We know how storage gets procured, gets managed, gets depreciated, gets updated on premises, and we understand kind of the capital burden of that. Every hardware vendor at this point has tried to build a financial program that allows you to do a just-in-time provisioning and a use-it-when-you-pay-for-it model, because that's exactly what customers are getting and then asking for out of their cloud providers. Everything that we're going to provide and everything that we'll talk about today is pay-as-you-go, is going to be scalable both up and down, and is going to be able to scale to sizes that it would be really hard to pull the trigger on if we wanted to do it on premises. So we recognize that cost effectiveness is going to be one of those deltas that you're going to have to look at when you decide what you're going to do. The second is going to be reliability. We have to do backups on premises, right? We have to do load balancing. We have to prepare for disaster recovery. In some cases, that's all part of the data storage product. Maybe it's part of my storage vendor, maybe it's part of my database vendor, but it's an operational process that you have to manage on top of whatever product it is that you have to, that you're working on. From an Azure standpoint, we want to provide these as built-in services. If you want to back up data off to third-party sites or to separate media, we want to be able to have that built in, and you can just select it as an option. If you need load balancing on front of it, because that's how we do maintenance, where we move from one database to the other and we don't have to rebuild applications and connection strings, that's something we need to be able to build in. And then disaster recovery or geographic redundancy, these are things that we don't want you to have to bolt onto these products. They're something that we want to be natural as part of the way the product is provisioned. And then finally, the storage types. In your data center right now, there may be a half dozen or more different types of storage that you're connecting to different applications or to different user groups. They may be files, it may be object storage, it may be NoSQL databases, it may be simple tables, it can be queues that you're using internally to do signaling between apps. There can be lots of different types of storage there, and we know that managing each of those independently is going to be a challenge. Being able to consolidate that down and drive a single management experience, a single administrative experience for each of those, and still give the end users the flexibility or the familiarity of the products that they've been dealing with is important. So let's talk about Azure Storage Accounts. Azure Storage Accounts are going to be one of those foundational things that if it's not the first thing you do when you log into Azure as a new user, because that's probably going to be setting up a VNet, it's going to be the second thing that you do. How many of you in here right now have provisioned a storage account inside Azure? That's not bad. That's more than I thought. Okay, so a storage account for us is a logical construct. It's the wrapper that we put around. We're going to create some type of storage and we're going to present it out to some type of endpoint. There are 5 different types of storage that we can provision out of that storage account, out of that container. The first is going to be blobs, or binary large objects, and this is your object storage. Whether you're deploying it through the user interface, whether you're deploying it through Cloud Shell, whether you're deploying it through a PowerShell script or through the AZ CLI, this is going to allow us to stand up an object store that we can connect to programmatically from anything that needs it. And whether that's a end user based application or whether that we're using it as a data store for a front end app that has to be pulling, reading, or writing data into it. It's an object store that we can make REST available through the REST API, and that we can distribute as much as we want to. The file system itself can store up to 8 terabytes of data. It's available in hot, cold, and archive tiers, and it excels at storing either very large objects or large collections of objects that we need to be able to access randomly, or large objects that we need to be able to stream. The second type of storage that we can provision out of a storage account is files. These are going to be your file systems that we're going to connect to an end host, right? We support SMB and REST, and SMB allows us to connect that storage endpoint to any OS that's on the other side. We can connect it to Linux, we can connect it to Microsoft, we can connect it to Mac OS. Some of you are sitting there thinking, does this support CIFS? And shame on you. There's no CIFS anymore. SMB is that universal protocol that allows us to take a file share and push it out to any endpoint that we need to. This is going to be great for document sharing. This is going to be great for things where what I need is a directory structure that can be attached to and that can be worked in from multiple people. The third type of storage is a little special because it's specifically made for messaging. So it's a system where you can have multiple senders and multiple subscribers, and basically when a message arrives, the subscribers are notified and they can do something. The messages can be 64K in size, so they're just big enough to carry a payload. And one use case for this is that you can use it to allow services that you have running on premises to communicate with services that you have running in Azure without having to do a direct integration between the two of them. If we have something that's running on premises that we need to be able to message an Azure application or an Azure app function to go do something when this trigger is hit, queues would be the place that we want to be able to do that. For example, we could use a function to forward a message to a SignalR server that could then push a notification out to an iOS or an Android endpoint that something happened, whether that was on premises or in something that we've built inside Azure, so that we know that thing, whatever it was that happened. So queues is another type of very specific storage that gets provisioned directly out of a storage account just like the rest of them. The next one is going to be tables, and tables is one of my favorite because it's a very good entry point into the world of Azure storage and Azure databases. So tables is going to be a really simple NoSQL way to store data, right? Think of it as it's a key value store. It's very easy to access, it's very easy to set up, it's very scalable. You can store petabytes of data in there, particularly if you shard that database out across multiple instances. It's not going to be as performant or as resilient as, say, Cosmos DB, but it's also not going to be as heavyweight to deploy it. What I use it for in particular, and something that we see lots of customers use it for, is I have an idea. And I say, it would be really cool to build this thing that does that, and I just need somewhere in the back, almost like a scratch table, in order to be able to write values in or read values out. And I try it, and it works, and then somebody likes it, and we get a team of people working together, and at some point, we say that doesn't need to be in tables anymore. We need to have the data closer to our customers. We need to have more resilience. I need to be able to guarantee latency. Whatever the reason would be, we can use this as the entry level to then step up into a larger, more distributed, more performant Azure service to be able to use. The last data type that we're going to look at are disks. Disks are fundamental for virtual machine instances. But they're also things that you can attach to lots of different objects as you need more capacity or you need a different type of capacity or performance to attach to it. We have multiple performance tiers for the disks. We have high performance flash, we have SSDs, we have spinning disk. You can choose that mix of price and performance based on the type of data you're storing and what it's being used for. When you create a VM, it will automatically create the OS disk based on what it is that you've asked for inside the VM from a performance standpoint and from a size standpoint. But then you can connect any type of disk to that VM for the data side of things, or if it's a virtual appliance or something like that, based on whatever specifications that you're getting from the software vendor. So we want to be really flexible with this. Again, like all of these are, you have the ability to access them, to provision them, to tear them down, to resize them, to do anything that you want to through all of the different types of Azure automation. So we can do this with ARM templates. We can do this through the REST API. We can do this through the Azure CLI, all of the different places that we have to be able to interoperate with the objects that we're provisioning in Azure. This will follow the same rules as everything else. The best part about all of this is that we're going to build all of this on top of a unified and distributed storage architecture, storage system. Once you know how to work with one data type, once you're comfortable working with files, moving over and working with blobs is going to feel the same. It's going to have the same interface. It's going to have the same nomenclature around what is it called or what does it look like. We want to try to make it as easy as possible once you get into a storage account to move side to side across it and be able to provision the different types of storage as you need them. All of this is going to inherit the benefits of that overall Azure storage. That's going to be the durability, and we'll talk a little bit about how we manage reliability and replicas and those sorts of things. Everything is going to be offered encryption at rest, so when the data is written to the disk and it is sitting on the disk, it will be encrypted. We can extend that out to in-transit as well, and we'll talk about that. We're going to get a strongly consistent replication platform. So for all of the data, being able to distribute it across multiple data centers or multiple regions, and we'll show some examples of that here in a second. And then all of the auto load balancing, so that no matter how many replicas there are across how many regions, it's the job of the storage platform to make sure that those stay consistent across all of the different instances. The more we can invest in that bottom layer, then the more of that gets inherited up by the individual storage types that you're provisioning. Speaking of encryption, now that we know that basic structure, let's look at this and then replication and resiliency, or replication and redundancy, that are really the two biggest ones, particularly for customers who are coming from an on-premises storage environment that they're looking for. So Azure is going to include all of the tools that you need in order to be able to manage the security and compliance to match or exceed what it is that you're currently doing on premises. So the storage service encryption automatically and transparently encrypts all of the data before persisting it. We're going to use our own keys to be able to do that by default. We will certainly allow you to manage your own keys in order to be able to do that encryption. It is provided by default. It is turned on by default using the Azure keys, and it's included at no additional cost. There's no upgraded storage level that includes encryption. That's how it works out of the box. This is available for all of the different things that we just talked about, universally across that storage account. So whether it's the managed disks, blob files, queues, tables, it's going to be able to, we're going to be able to encrypt all of that. We also support encryption during data transport. So data passing between Azure data centers using the Azure VPN is automatically going to be able to use SSL or TLS. It's going to be able to use HTTPS. If you're using ExpressRoute between an Azure data center and your primary facility, your on-premises data center, all of that is going to be encrypted from end to end. Every transaction made through the Azure portal, so all of the provisioning and automation is all going to be protected with HTTPS. And we will only accept encrypted disks when we do onboarding, like when we do imports and exports of disks. We won't do those in an unencrypted fashion. We do support FIPS 140S ciphers as well. So if there's a formal requirement for the certification needed to be able to say, yes, this is encrypted and here's the standards that it adheres to, we can certainly make sure that we provide that for you as well. On the redundancy and replication side, this is where it's important for you to understand the way that you're using the data and how it is that you want the data to relate to your customers. Everything we provision inside a storage account is at minimum going to be what we call locally redundant, LRS. Locally redundant storage means that every piece of data is going to have 3 replicas, and all of those replicas are going to exist in a single region. This may be in a single row of a data center inside that region. It may be on different floors in that data center. There's no guarantee as to what the proximity of that those replicas are, but there will always be 3 replicas. And what we're trying to protect against here is the storage servers on the back end that are actually hosting that data, that something goes down and that just becomes transparent to you. Right? We mark everything as bad, and we re-replicate all of the data back out so that we've got 3 replicas again, and everything works the way it's supposed to. This is going to be great for what I would call non-production work. This is going to be great for testing. This is going to be great for places where I'm willing to have my data exist inside one Azure facility. Maybe an Azure facility is already a step up from where you've got the data stored today, and that's enough for you. But this is going to be 3 replicas, single region. The step up from there, saying I like this 3 replicas for my data thing, but I would like it to exist in multiple regions, would be GRS, or geo-redundant storage. This is going to be the exact same thing as LRS, except we're going to do it across 2 regions. So it'll be 2 different physical Azure data centers, and we're going to do an async replication between the 2 of them. The primary is still for your reads and your writes, and then the secondary would only become available in the case that the entire first environment goes offline. So if an entire Azure data center dropped off the net, the load balancer will push all of those storage requests over into the secondary region. If the GRS sounds fun, but we need the data to be read closer to where our customers are, meaning I'm not putting copies of the data on the East Coast and the West Coast of the US because they're far apart, but that's because where my customers are, then we can do read access geo-redundant storage, or RAGRS. What this gives us the ability to do is to take the GRS model of having things in multiple regions, but then also allow that secondary region to be read from directly. So we're still going to async between them, but that secondary copy is going to be online for reads even while the primary copy of that data is up and running. And the last one we're going to call zone redundant storage, or ZRS. And this is available in some Azure data centers today and is being quickly rolled out into all of them because it's proven really popular by customers. What this is I'm still going to have 3 replicas, and it's still going to be in one region, but the region itself is then spread into individual zones. And those could be different floors of the same data center in some of the smaller regions, or in most of the regions, this will be 3 different data centers on the same campus. So low-speed networking, high-speed networking, low latency between all of them, and those replicas are just spread into places where if we had a facility go offline, or if we had a power connection go offline, the other replicas of that data would be protected by the other data centers that happen to be in that region. So this is available in most of the larger regions around the world, and is something that we're pushing down this concept, not just for the storage, but also for compute and networking and all the rest of the infrastructure services that we're offering. All right, let's do a demo real quick. Let's talk about creating data stores in Azure. All right. Everybody see that in the back okay? Awesome. Very cool. So we're here at the Azure portal, and this is our default generic homepage. You can see all of the recent resources that I've accessed. We can see the Azure services across the top. We're going to create a new resource. And when we come into this create a new resource screen, you'll see on the right side all of the most popular services that customers are deploying in Azure. And then on the left side, you can see broken out by type of resource or type of product so that we can click through. For these most popular ones, one of the more interesting things that we have here is this idea of a quick start tutorial for everything. And the quick start tutorial is really going to be focused around, I don't have a whole lot of experience with this, or I have lots of experience with Azure, but not with this specific service, and I need to get up and running now. So it's a series of 5-minute quick starts. Some of them are text, and you read through them. Some of them are videos, and they're designed to help you do very specific things. We've also made those available across all of the different contexts that you might want to use them in. So in this case, we can see Do I want to create a storage account? Do I want to create a blob, an object store to get up and running quickly? And I may want to do that from the portal. I may want to do that from PowerShell. I may want to do that from the AZ-CLI, from the Azure command line interface. Or I may programmatically want to do that through .NET or Java or Python or JavaScript. So we're going to try to, with all of those services that we saw on that page, give you a quick start that lets you immediately jump in with your context and get going the way that you want to. In this case, we're going to create a storage account. Some of this is going to be pretty straightforward. Like any other service that we create, we're going to have to pick a subscription to put it in. We're going to have to pick a resource group that we want to put that in as well. And then we're going to give the instance some details. And we'll call this one AFUN50 Orlando. We're probably not going to want to deploy this in Western Europe. I mean, we could. Maybe that's where our users are. Maybe that's where we want to. We will put this in, we'll put it in Central. Nah, we'll put it in East. We'll put it in East US. Now here's where we can pick our performance. Do we want this to be standard or do we want this to be premium? The account kind is going to be the version of the storage API that we use in front of it. If you need compatibility with something that you already have that exists, maybe you want to look at something other than V2. Otherwise, we don't need to mess with that at all. And then here's where we can pick the replication type. And so in this data center, we do support zone redundant storage, which is why ZRS is one of the options. That read access geo-redundant storage is going to be our default. So it's going to spread it across 2 different regions, and both of them are going to have read access to it. And then we can pick the access tier that we want. Do we want to make this hot data, meaning it's going to be promoted, it's going to be instantly available, or is this something that if it takes a couple seconds for us to get a return from a read request, that's not going to break anything, and maybe we put this on the cool data. We're going to hit review and create, and just like everything else, it's going to come up, and it's going to give us the ability to download a template for automation. So if I was going to do this over and over again, I can pull down the ARM template to be able to build that out. And once the validation passes, we just tell it to create. Now for this one, I've created a public endpoint for it, right? We want to be able to front this with a web service or something along those lines. But we could also make this so that it only talks internally across a VNet to resources that you've already put in place. So we can make this a public service that we can then proxy out through a public IP address or a DNS name, or we can have it be something that's just focused inside the data center. Our deployment is in progress. And as this goes through, we're not actually provisioning any storage at this point. What we're really provisioning is that wrapper that goes around the storage that says, this is an account that I have the ability to then deploy my blobs or deploy my files into. So as soon as this finishes up, what we're going to do is we're going to go into it and we're going to create a file store. We could create an object store if we wanted to. We could create a table if we wanted to. But what we're going to do is something that is easy to work with and easy to attach to directly. So we see we've got our container that's here. And you like how I talked just long enough for it to be created? You never know how long that's going to take. I'm really proud of myself. And we're going to go in here and we're going to create a file share. And it's going to come up and it's going to show us all of the file shares that we have, which at this point, since we just created this storage account, we don't have any. And we're going to add a file share in here. And we're going to call it something brilliant, like my files. And we're going to give it a gigantic quota of 1 gig. So there's my files. And I can do a couple things here. I can browse it, right? I can actually go in and I can see that there's no files found. I can upload files into it. It's just like any web store. One of the interesting things that we can do here is there's a little button called Connect. And whether I'm connecting this to Windows or I'm connecting this to Linux or I'm connecting this to Mac OS, what I have is all of the scripting that I would need to be able to create that as a storage object on that host. So if I wanted to map this to a Windows box and I wanted to use drive letter Y, there is the PowerShell command for me to be able to identify that that storage object is up. It'll do a test to make sure that all the networking ports are open and there's a When we move into it, there will be a whole help of here's all the stuff that needs to be opened through the firewall on your side, that sort of thing. And then it will go ahead and map that drive. And I go into Windows Explorer and I refresh, and it just shows up as a map drive like anything else, except it just happens to be mapped to that file instance that we created inside the storage account in Azure, rather than an SMB share off of a standard Windows file server that happens to be sitting inside. And I can do that to every server that I have deployed, whether that's on premises or whether that's in Azure. Anything that will accept that, any OS that will accept that connection string, we now have a distributed, right? It's being protected across 2 different Azure regions. Scalable, we started with a gig, we can make it as big as we want to. SMB file share that we can connect to any endpoint directly out of that one storage account. And once we do that, it works just like any other SMB file share would. We can copy things up, we can bring things back down, we can look at it whether it's through the web interface or whether it's directly through the Storage Explorer. Some of the other interesting things that we can do, let's go back to the storage account. One of the interesting things, then this is fairly new, is we have the ability to take a storage account and use it as a static website. And I know that there are tons of us who had built sites on WordPress or something that was a very dynamic back-end kind of server-heavy infrastructure. And for those of you who are moving, whether it's for your production work stuff or even for things that you're doing on your own, to a static website where you're serving all of that data and then letting the client do the rendering on it, this is a great option to be able to stand up that storage and just say, I want a place to be able to copy up all of my static server files, and then we'll let the client do the rendering, and we can do that natively out of the storage account. We don't have to add anything special onto it. So this one is one of those ones that we asked for it and asked for it and asked for it, and they finally gave it to us, and customers are finding out about it, and I've had probably 6 or 7 people come up and ask exactly what can we do with this and how far can we push it. So this is just another one of those features that will be available to every storage account, along with the rest of the things, like we can look at endpoint security if we wanted to be able to authenticate the endpoint before it connected instead of just using the connection string. All of these things are going to be available out of every storage account. We picked a simple one, build a file share, connect it out to an OS, but I hope that gives you kind of a good overview of what the pieces are and how it is to provision that in there. I don't want to get away from this without giving you some resources. So if you browse out to the URL that's down at the bottom there, aka.ms/storagedocs-AFUN50, this is going to be all of the documentation overview of the storage accounts and then all of the different pieces in there. It's going to get you out to your quick starts. All the things that you need to get started with is going to be down there. There's also a Learn module. There's an entire collection that we put together just around the core cloud services. So if you want to do something kind of internal personal training wise that's not a full-blown certification, the MS Learn stuff is great to be able to dig into something with, dig into it fairly deeply to figure out how it works and what it is that you can do with it. So both of those are available for you. We're going to do a quick introduction to Cosmos DB. When we look at that overall modern data estate, the Cosmos DB sits over here on the left with the non-relational databases, the NoSQL databases. Cosmos is our globally distributed NoSQL database offering. The interesting part about it is the flexibility that we have around addressing it on the front end. So all of the things that you see across the top there, Table API, Cassandra, Spark, Mongo, Gremlin, we have APIs that allow those command sets to be used directly against Cosmos DB. So if you're using any of these on premises and you want to be able to build directly onto Azure or move things into Azure, this gives you, much like the storage account has lots of different storage types, Cosmos DB has lots of different API interfaces for us to be able to use so that we can continue to use the tools and the know-how that we have without having to move things completely over in order to be able to take advantage of what we're doing inside the cloud. From a global solution standpoint, the data is going to be distributed and available globally. We'll do a quick demo of that. We can enable latency-sensitive personalization, so we can decide how little latency or how much latency we want a connection to have. Because it's predictable and fast service, even during traffic spikes, it makes it great for things like gaming, e-commerce, and IoT. We can run analytics directly over the operational data, so we have a plugin for Cosmos DB directly into Spark or Databricks, which is the managed Spark service from Azure. And then you can lift and shift your NoSQL data, whether that's MongoDB, whether that's Cassandra, without any translation to the code that's running on the front end because of those APIs. The distributed nature of this is really important, and I think that we want to focus just a little bit on that. We have the ability to distribute everywhere, much like CDN solved the problem for how do we get data close to customers for static content. Cosmos DB wants to solve that for dynamic content, if there are things that need to be generated out of the database. Let's jump back over into, do that the right way. Let's jump back over into here, and we will look at a Cosmos database. And this is one of the ones that we're going to be using. There's a whole track around migration. How do we migrate things into the cloud? There's a couple tools we'll use there. This is one of the databases that we're going to use, and you can see over on the left, we can see our connection string. We've got a global connection string, so as we add and remove places that we're storing this data, we don't have to go in and update the applications. We're pointing everything at the load balancer, and it's pointing it across all of the regions or doing it intelligently by where that traffic is coming from. And we can see that we've got Cosmos DB. This is a tier 1 service for us. It's available in every region that Azure has a data center. And we can go through and we can select. In this case, we can see it's already existing in US East and US West. Let's say we wanted to put a copy in West Europe and in Hong Kong and in Sydney. We simply check the box that's in there, and now we get, do we want it to be read and write? Do we want it to be archived? Do we want multi-region writes on there? Do we want to be able to write to all of these different copies and then have them eventually become consistent across them? And when we hit save, it's just going to start the replica in the background. And depending on how much data is in there is going to be how long it takes for all of the replication to finish. And once the replication finishes, those instances of the Cosmos DB data set will come online, and the load balancer will start sending traffic out to them based on the pattern that we have. So this is, of everything that Cosmos DB does, if there's 2 takeaways I could give you, it's globally distributed and super flexible around how we manage consistency and performance, but then also multiple APIs in order to be able to access it on the front end so that we can migrate from tools that we're already using or platforms that we're already using in. I haven't messed that up switching back and forth yet, which is really cool because I always mess that up. So we're doing okay so far. Docs alert, if you want to know anything about Azure Cosmos DB, there's the link down at the bottom for you to be able to pull that up. It will work the same way that the other ones do. It'll take you right directly into the quick start, things that you can work on. SQL Server is obviously kind of one of those foundational elements from a Microsoft standpoint that's powered on-premises environments for a while. When we look at that data state, again, here what we're talking about on the left-hand side are the relational database corollaries to the NoSQL Cosmos DB. Azure SQL Database is the database server, the database instance type that you know, just delivered out of Azure as a service. So it's going to be completely compatible with every SQL instance, every SQL version that you have online today. We are going to be very flexible with the licensing and the hybrid cloud benefit between the on-premises licensing and the Azure licensing, which is going to help with the TCO and the overall cost of the product. We can scale up to 100 terabytes of on-demand storage per database. So we're trying to drive as much performance and flexibility and scale as we can. We're going to offer multiple layers of security on top of that with the SLA, and then all of the services that you would add on to an existing SQL instance are going to be available directly. The one that I wanted to focus on here was machine learning. Today, if we want to build machine learning into an on-premises SQL database, We have the application sending transactions to the database. We then have to move the data or copy the data into the analytics service where we do the data transformations and the model training. And then we send that model off to be scored and optimized to a separate service or embedded logic within that. And then any new data from the database has to go through that same process. It's not impossible. There's just a lot of moving of blocks of data from piece to piece that ends up limiting how large it can get or how fast we can make it. For the Azure SQL database, all of the machine learning is built into the platform. So whether it's the transformations, whether it's being able to score that, whether it's figuring out what it looks like, and then being able to send those predictions back to the application, all of that can be managed right directly inside the instance. Doesn't impact the overall performance of it. It's included as part of the service. These are going to be things that are built right directly into that. We also help you with the migration journey, and whether it's going through the pieces of it, or whether it's doing that completely as a service with something like the Azure Database Migration Service, allowing customers to move like database to like database, moving a SQL Server into Azure, whether it's moving across platforms, if we wanted to move an Oracle database or a MySQL database and we wanted to move that into the platform. We try to make that as flexible as we possibly can for customers who are trying to move over and get started. The last docs alert that I want to be able to give you is going to cover all of the SQL data warehouse. How do we aggregate all of the data across multiple databases and allow it to be available to analytics on a global scale, on a grand scale? And then how do we automate collecting all of that data and then processing it through that engine so that we can get there easily? If you have questions about those, the two links down at the bottom are going to cover Azure SQL Data Warehouse, kind of the grown-up giant data lake version of Azure SQL Database, and then the Azure Data Factory processing components are going to be down there at the bottom. In summary, Azure is going to offer we could talk about this for days, a huge variety of options for storing data in the cloud, whether it's scalability, reliability, simplicity, the built-in intelligence that we're going to put on there, whether it's fully managed, whether it's globally available. We have lots of different benefits there that when we stack them up side to side, say that Azure is going to be a good place to put that. There is a specific Azure Data Engineer certification. If you are interested in this, there's more information at the link down there on the bottom, which is good news to have because everybody at Ignite gets a free certification exam. So if this is the place where you're focused internally and the place that you want to kind of plant your flag on the Azure side, we've got both a certification and the certification exam for you. And then my contact information is on here. That's my Twitter handle. If you have any questions, if you want examples of how things work, if you want to know where inside the Azure portal to go and play with things, please reach out and let me know. But thank you for participating in kind of this first run through of the Azure fundamentals. I hope that it was useful. I hope that you learned something. And we're really glad that you're here at Ignite. So enjoy the rest of the day.